been done. With the Antarctic, you really have to use a boat because you've got to cross this ocean, and the narrowest place to do it is between the bottom end of South America and the Antarctic Peninsula, which is the way that we're going. We're somewhere here at the moment, we're heading down to there, and then we'll cross the Drake Passage and head for the northern end of the Antarctic Peninsula. So let's just have a slightly closer look at Antarctica. Hang on, there we go. So traditionally it's divided into two sections. There's a larger section in the right of this picture called East Antarctica, and a smaller bit called West Antarctica on the left. Now, if I'm absolutely honest, it rather depends on which way you look at it as to what you decide is East and West. It's a little bit academic, but anyway. So they're divided by a mass of the transantarctic mountains there, and so you've got this big mountain range going across the middle, and this area is basically one massive great ice cap over there, and this is an area much more mountainous, and the mountains extend right the way up along the Antarctic Peninsula, and these are actually an extension from the Andes. So if you saw Sarah's talk this morning about the Andes Mountains, which come right down to the bottom end of South America to Patagonia, in fact that arc of tectonic plate extends right around past the island of South Georgia there, South Sandwich Islands. You can see that sort of curve as is marked on the map. That's basically underwater mountains plus a few islands, and then that continues down along the Antarctic Peninsula. So the Antarctic Peninsula is basically an extension of the Andes Mountains. And one reason that we tend to go there, that is basically the Antarctic Peninsula is the area which is most visited by tourists. And I would say about 98% of tourist visits to Antarctica are to the Antarctic Peninsula. And that's really because it's got the closest landmass. So it's easiest to get to. So you come across from South America at 600 miles across the Drake Passage. Whereas if you want to come to another part of Antarctica around here, you have to come from either, wherever it is, Australia, somewhere there, I think, and left off the map, so you have to cross a much greater bit of ocean, or South Africa, you can go from over there, and you have to come right across there. So this is obviously, the southern tip of South America is a very good access point. But the other reason we're going to the Antarctic Peninsula is because crammed into a relatively small part of Antarctica is sort of huge riches in terms of scenery and in terms of wildlife. So it is one of the most extraordinary and beautiful parts of Antarctica. And one of the reasons for the wildlife is because there's a lot of exposed rock down near the coast, and so animals like penguins can come ashore and they can breed on the coast. And so you've got this massive wildlife that uses the landmass of Antarctica. Now, one thing about the wildlife in Antarctica is they only need land to breed. Most animals are marine animals. They are dependent on the marine ecosystem for food. And I'll talk a bit more about that later. But you can see why, because it's basically it's surrounded by sea. In winter it all freezes over anyway. And so the only food source is in the sea. So they're all sort of animals that rely on the sea for food but come ashore to breed. And that's a sort of critical point about the wildlife. So let's have a look at some definitions of what is Antarctica. Which bits are Antarctica? Can you define it? There's a landmass there, but there's also lots of offshore islands. As you'll see in a minute, the whole continent expands at one point in the year and then contracts again. So how do we define Antarctica? Well, we could say, let's say Antarctica is all the landmass inside the Antarctic Circle, which is a geographical circle you can put on the map about there, 66 degrees, 33 minutes and 49.8 seconds south. And the Antarctic Circle is defined as the point north of which you, hang on a minute, let's get this right, south of which, on the longest day of the year, you will see the sun 24 hours a day. So the sun will stay above the horizon. And in winter, it will stay below the horizon for 24 hours a day. But as you can see from the map, that actually cuts off quite a lot of landmass, including the bit we're going to up there. And actually, this map's not quite accurate, but the Antarctic Circle doesn't actually include quite a lot of promontories sticking out on this part of Antarctica as well. So although geographically and sort of astronomically it's an important circle on the map, it's not in a sort of practical, it's not a very practical definition of Antarctica. So for many years now, the definition of sort of Antarctica has been 60 degrees south. And 60 degrees south, which is this map here, that big black, that dark black circle there, and that encompasses all the Antarctic continent, plus the Antarctic Peninsula, and the South Orkney Islands and the South Shetland Islands. Outside that, there are a number of islands all dotted around here, which are claimed by various countries like Australia or South Africa, or the UK, in that case of South Georgia up there. And all these islands are sort of sub-Antarctic, and they're sort of politically they're outside the Antarctic region and outside the definition of Antarctica. But they very much lie within the biological area of Antarctica, because the biological area of Antarctica is defined as all the area within an area of cold water ocean that surrounds Antarctica. So let's have a look at that. And that dark black line defines the Antarctic convergence, which is where the cold water of Antarctica meets warmer waters further north. And the cold water is the sort of critical bit which drives the biological diversity and the sort of basically the quantity of wildlife that you get in Antarctica. Just very quickly about the rationale of, here we are, we've got the Antarctic convergence just marked on the map there. I'll talk a bit about the Antarctic convergence later on, actually, about why cold water is important in Antarctica. Now, when I said the whole continent sort of grows and then shrinks again, it's actually because during the winter, it does change dramatically. So in winter, the sea is so cold that it freezes, and it freezes out from the Antarctic continent, and the map on the left here gives you a sort of, it varies over the years, to be honest. It gives you an extent of the sea ice that forms during the winter. So this is only temporary ice, but it does effectively, as you can see, effectively double the size of the Antarctic continent for a few months of the year. So that ice is just basically frozen sea, and it freezes out, and then when the summer comes along and it gets warmer, the sea ice breaks up and shrinks again to roughly the sort of areas you can see on the left here. Now there's some pale grey areas in here. You can see that one there, a really big one called the Ross Ice Shelf, and the one there. And these pale grey areas are also floating ice, but they're ones that are permanent and don't melt during the summer. So the sea ice obviously expands from them, coming out here, but then it melts back to them. But you get a sort of ice age, which does change, obviously, but basically that's a big floating area of ice in there, which is fed by glaciers coming down from the Antarctic continent. So there's sort of permanent ice, there's sea ice that comes in the winter and then goes away in the summer, and then there's all the continental ice stacked up on top of this continent. Let's have a few kind of extremes. Antarctica is an extreme place. It's one where you can't really imagine this, but it's actually, the Antarctic is actually a desert. It's a cold desert. Okay. You think, well, it's got that water in it, but actually it has very low precipitation, and so it is in fact a desert. So we'll have a look at a few. Hang on, what did we think of the wrong way? It's obviously the coldest continent on the planet. It's one of the coldest places on Earth. Coldest temperature was about -89, measured at a station called Vostok, which is way up on the plateau in East Antarctica. And so it gets very, very cold indeed, and it's cold most of the year round up there. Around the coast it gets much warmer. And in fact, the sort of temperatures in the middle of the summer that we're going to experience, probably not much. I mean, if we get below freezing, it'll be unusual. It might be between 0 and 5 degrees, something like that, around the coast of the Antarctic Peninsula in summer. So don't panic. Okay. You're not going to need, the great big sort of Michelin suit, sort of massive padded stuff. You need some cold weather clothing. When you're out on deck, you're going to need some gloves. you'll need a hat, something like that. But you can always, on the ship anyway, you can always pop indoors and warm up. So don't panic, you're not going to freeze to death or anything like that. So it's also the highest continent on average. And that's because you've got this incredible build-up of ice. I mean, most of that height is just a massive great block of ice, which gets up to about 5 kilometers thick, which is 3 miles. So in the middle of Antarctica, you get, if you're standing on top of the ice cap, you've got about 3 miles of ice below you. So it's an immense volume of ice. And so it is actually one of the highest continents as an average height. It's also one of the windiest, and that's because you get these, because you've got a huge cold continent and you've got warmer air all around the side of it, so you get a differential sort of pressure systems and differential temperatures, and that creates a lot of wind. And it's also, as I was just saying, the driest, which does make it a cold desert, technically. So those are the sort of extremes, the coldest, highest, windiest, driest. A sort of slightly odd combination of things, really, in a way. And as I say, when you think of all that snow, it's all water, but actually it's frozen, and there's not much adding to it every year, which does make it a desert. So if you take a sort of bit of it's almost a cartoon view of a cross-section through Antarctica, the actual land mass goes up and down significantly. It's the brown bit at the bottom of this image. And you can see actually some of it's below water. I mean, it's below the sea level. Sorry, not below water. It's all below water because it's covered in ice. But that's the sea level there, and you go across, and actually these bits, some of those are just about below sea level. So if all the ice melted, you'd actually have a series of islands. You'd have one big land mass and lots of little islands dotted around the place, and it wouldn't look anything. The map would look completely different. In fact, a lot of things would look different, which we'll come on to in a minute. But you can see why it's, on average, the highest continent on Earth, because you've got this build-up of ice, this huge ice cap, 2,000 meters, that's about 6 and a bit thousand feet, for quite a long way across there. So that, raised the average depth of that's quite big. The average height is incredible. You've got some mountains which go just above the height of the highest bit of ice cap. So these Antarctic mountains are pretty big, and yet there's some areas which are very low around them. So the actual sort of under ice geography is quite dramatic and quite extreme, and more so than you might think. You just think it's just a great big lump of ice, but actually what goes on underneath is quite varied. If you get a closer look at the Transantarctic mountains, they're actually quite impressive. They go up to that's about 50,000 feet, I think, and these are some of them. That's a particularly spectacular rock face. These are pictures from a friend of mine, for which I'm very grateful. But that's a 5,000 foot or 1,500 meter rock face, just one big slab of rock. So as you can see, and again, if you were at Sarah's talk this morning about how mountains are formed, there's been some pretty serious forces coming out of these mountains. Big glacial pressures are kind of just carving away at these rocks and creating these spectacular peaks. The highest mountain in Antarctica is Mount Vinson. It's just around 16,000 feet, as I said just now, 5,000 meters. That's it in the background there, behind a field camp. And in fact, it's interesting, just one little note about this picture is that the field camps, they still use these old-fashioned pyramid tents, which are pretty much what Scott and Amundsen and people used in the old days, and they still use them, partly because they were a really excellent design. They're not exactly lightweight. You have to have, they're made of very heavy canvas with very heavy poles and all the rest of it, but they do stand up, and once you've got it standing, because they're pyramidal shaped, it doesn't really matter which way the wind's coming from, and you can be quite snug inside them. So that's a couple of very old-fashioned looking tents, but they're very solid, and I think the British Antarctic Survey still uses them. Okay, we've got all this massive ice on top of this continent, and let's have a look at some of it. So, if you go up on top of Antarctica, again, this is not my picture, a friend of mine gave me this one to use. This is a picture And you think, well, what's the perspective here? Are we standing on this, or are we looking down at it from space, or what? Antarctica does a little bit do that too. Distances and scale is often very confusing. This particular image is taken from an aircraft about 1,000 feet above the surface. So you're looking down on this big ice cap, and you can see it's not particularly flat. Imagine if you were skiing across there or pulling a sled to the South Pole or something like that. It's actually quite bumpy, and it could be quite difficult terrain. So, a pretty obvious question is how much ice is there? And from all the pictures I've showed you so far and the numbers and the kind of illustrations, there's quite a lot. Okay? If you want to put that in numbers, which frankly mean almost nothing, I mean they mean something, but 28 million cubic kilometers, well, I think I'd have a bit of a job, trying to visualizing exactly, what that is in terms of Olympic swimming pools. Probably about 4 trillion, but it's for the imperial minded, it's 7 million cubic miles of ice. So that's a lot of ice. Let's have a look at what that means in terms of sort of global ice amounts. So it's 98% ice cover over the continent. So most of Antarctica is just covered in ice without any bare rock. Most of the bare rock that you see either sticks up in the Transantarctic Mountains or is down by the coast and is where it's warmer. So and you get these rocky promontories sticking out, which are the ones where the penguins breed, and the area which makes the Antarctic Peninsula so diverse in wildlife. But most of Antarctica is covered in ice. It actually contains 90% of the world's sort of constant ice, basically. Most of the other 10% is the Greenland ice cap. So the Greenland ice cap is also fairly massive. And then there's other bits, like the Patagonian ice caps, there's bits in the Himalayas, the Alps haven't got much left, Alaska's got a few bits and bobs. So there's various other bits of ice around the world, but mainly it's Antarctica and the Greenland ice cap. They are the biggest, the two biggest ice caps, of which Antarctica is, 9 times bigger pretty much. So it's a very, very significant ice cap, and it also contains 68% of the world's fresh water. So, that's of all the fresh water in the world, including the rivers and lakes and everything else. So it's a very high percentage of the fresh water in the world. I think about 20% of it, much of the other, about 16, 17% of it is actually in Lake Baikal apparently, in Russia. So that contains another large quantity of the Earth's fresh water. The average thickness of Antarctic ice is 2,300 meters, which is 2.3 kilometers. That's about 1.3 miles, something like that. It's the average thickness. And the, maximum thickness is 5,000 meters roughly, which is about 3 miles. So you've got about, say about 3 miles of ice under your feet, where you're standing right on top of the Antarctic plateau. Right, that's a different picture as background, but a few more icy facts. What if it all melted? Whoops. And it's kind of a question we need to ask ourselves these days, for obvious reasons. If you just do the math, as they say, the sea levels would go up by 60 meters. That's about 200 feet. So if all of Antarctica melted, the world sea levels would rise by 200 feet, or 60 meters. That would cover most capital cities in the world. It's the sort of time where you'd want to be living in somewhere like Bolivia, where La Paz is, I think, 10,000 feet up. And so you'd be fairly safe up there. But many of the other ones, including, London, New York, the whole lot, Sydney, that sort of thing, Auckland, I think we've got some New Zealanders here. All those ones, Buenos Aires, that'd be underwater, they'd be just gone, most of them, if the sea level rose that much. But it's it's extremely unlikely that the whole of Antarctica melts. So you're okay. However, let's imagine that only 1% of Antarctic ice melted. Then we only have 1% of that sea level rise, which would be 0.6 meters, which is about that much, okay, off the stage. So if the sea levels rose by about 2 foot, you'd think, that's not a problem. Until you realise that 150 million people would be homeless. So we would have a problem. So Antarctic ice, it's very important that we keep it in Antarctica by what we do by the rest of the planet, which I'll have a chat about in a minute. Without wanting to be too dismal about it, let's look on the bright side. Ice is really beautiful stuff. You can see the background to that picture. That was a chunk of black ice, which I photographed a few years ago. And ice, everyone thinks of what colour is ice? Ice is white. No. Ice is almost any colour you want to throw at it, or any colour that reflects or refracts through it. And it can be amazingly varied, and I just love photographing ice, and I love looking at it. It's very, very beautiful stuff. This is a picture I took for National Geographic a few years ago, and here you've got this sort of white, uncompressed ice, and then some black ice, as we call it. You call it black ice. In fact, it looks green because of the ice, the light reflecting through it, and it's got these amazing sort of green stripes through it. So I think. One thing I would say is on this trip, we've got about 48 hours when we're going to be in Antarctica. Make the most of it, enjoy it. Just be out there as much as you can. Keep an eye out. You never know what time of day. Different times of day, the ice looks different. And if you're going past an iceberg or past some beautiful mountain scenery, and it might be this was about 11 o'clock at night, and we got this beautiful sunset, and the sun came sort of just very sort of, a very shallow angle. You've got this lovely sunset one way, and the rays of sun are lighting up this wall of ice, and it's incredibly beautiful. So however much you might be partying at 11 or 12 at night, do keep an eye open out the window and just see what's going on around you. Just for those 2 days, you won't regret it. There may be something happening. It's just a lesson for every time in Antarctica, every time I sort of think about, I must just go to sleep, there's something amazing happens and you sort of think, no, I can't go to sleep because this is incredible. And that's, you've got 2 days of that, so I really would encourage you to embrace it. One of the key features about Antarctica is not just the ice and the mountains and the scenery, it's the wildlife, and I'm sure that's why many of you are going. So I'd just like to do a very quick introduction to some of the wildlife that is in Antarctica. We won't see all of these things, but I'd just like to give you a sort of bit of a view of some of the kind of wildlife highlights. This is actually a humpback whale tail, and we may well see some of these. I'd say this is very likely, because the whale numbers in Antarctica have been increasing over the last few years. They're actually really impressive at the moment, and the middle of the summer, which is where we are now, is a very good time to see them, because humpback whales come down to Antarctica to feed in the summer, and so you just get this fantastic concentration, especially in some of the areas where we're likely to visit. So humpback whales are one thing we might well see. Now, just going back a couple of subjects, back to this comment that everything is dependent on the sea. So all these animals feed at sea and are dependent on the marine environment. And the marine environment is really important because A, it's kind of huge, it's all around Antarctica. It's also cold. And so you've got this huge mass of cold water. And you might think, well, cold and that far south, it's really unproductive. But actually, cold water contains more contained gas than warm water. So cold water has a lot of carbon dioxide. And also in the summer, it's got nearly 24 hours a day sunlight. So you've got masses of sunlight, masses of carbon dioxide, and that's exactly what plants need to grow. And you think, well, hang on a minute, he's talking about the sea, we're not talking plants. Well, actually we're talking phytoplankton, which are like plant plankton in the sea. And they thrive in these long summer days with lots of carbon dioxide in the water, and then so the things that eat them do very well because there's suddenly a huge blooming of phytoplankton. and that feeds this little animal called a krill, which is a shrimp about that long. And pretty much, I mean, it's an incredibly simple food chain in Antarctica. It goes phytoplankton, krill, everything else, okay? so krill, and you get billions of tons of it in the Antarctic Ocean in the summer, is basically the food source for most things in Antarctica, for whales, for seals, for penguins, for albatrosses, with a bit of variation. And some of them use fish as a kind of intermediate, so fish will eat krill, and then some of them eat fish, and squid do the same. So, but krill, you know, phytoplankton and krill are the basis of this very simple food chain. And that's because it's, as I say, because it's cold. In winter it all packs up. In winter there's very little sunlight, and the krill will go like this, and kind of sit under the ice, and nothing much happens. And then summer they suddenly go, woo, and they're all out again. And they start breeding like mad, and it all goes off again. So it's very much of a seasonal cycle. That's why everything goes to Antarctica in the summer. That's why penguins breed in the summer. That's why whales go there in the summer. It's why, you know, the whole thing works in summer. So here's another humpback whale, just because I like pictures of humpback whales, and they're one of my favourite animals. They're completely amazing, and as I say, we should be able to see some. The other marine mammals that we have down in Antarctica are seals. So, for example, we might get a weddell seal. You might see one or two of these on an ice floe. They're not common. I mean, there's plenty of them, but they're not that easy to see from a ship. But weddell seals are quite an important feature in the Antarctic ecosystem, as are crab-eater seals. Crab-eater seals are actually one of the most numerous large mammals on Earth, so pretty much second only to humans, actually. But you only ever see a few at a time. You might see a group of them on an ice floe, like there. I think they're mainly crab-eater seals. Yep. And occasionally you might get a weddell seal in amongst them or whatever. So it's always worth keeping your eyes open for you know, ice floes. You never know what you might see on them. Now, one of the other seals we probably won't see, but which is very numerous as well, are elephant seals, which are very distinctive. They've got these really big noses. You go a northern elephant seal, which occurs in California, and then this is the southern elephant seal you get around some of the sub-Antarctic islands. But they also go down to the Antarctic Peninsula to molt later in the summer, about this time actually. So if we get a view of some beaches, you never know, we might see one or two of these. But the really crucial thing about this is they illustrate how rich the Antarctic environment is in terms of numbers, because this ocean just supports vast numbers of animals. And so just elephant seals alone, if you ever get the chance to visit South Georgia, you might see something like that. You get these enormous numbers of elephant seals. I was privileged in my time as a scientist to be involved in a survey of these animals where we counted every single beach, well, the elephant seals on every single beach right around the island of South Georgia. And we sailed around it twice in a sailboat. And it was an extraordinary thing to do. And in fact, while we're on the subject of South Georgia, another animal that really illustrates the richness of the place, penguins. And again, we won't see these. These are king penguins on South Georgia, but it just gives you an idea of the sort of numbers that the ocean can support. Some of you, if you get to Falkland Islands, may be going on tours, and in fact, one or two of those tours do visit king penguin colonies. One penguin that we might see, this is the Gen 2 penguin, very distinctive because it's got a white patch across the head and a red beak. We may see these either on ice floes or on the shore if we get in close enough. You'll see them at a distance, but it's useful to show a bigger picture just so you get an idea of what they look like. So that's one of the animals that comes ashore and breeds on the Antarctic Peninsula during the summer. And they also breed in the Falklands, and they also breed on South Georgia and a number of other sub-Antarctic islands. And when they come ashore, they generally have 2 chicks, and they're very cute. Thank you. Yes, the response is fairly usual. They are very, very lovely things. And except, to be honest, when the chicks are getting this big, the colonies, they start off beautiful and pristine, with covered in snow, and they dig the pebbles out, make a nest, and lay their eggs, and then the snow gradually melts and melts and melts and melts, and then by the time it's all melted, then it smells pretty horrible. So they're better in pictures sometimes. Another penguin we might see is called a chin-strap penguin, for very obvious reasons. They've got this black line under the chin, which is very distinctive. So that's another penguin we might see up in the South Shetlands. Maybe if we get towards Elephant Island, you quite often see them in the water there because there are big colonies in the area, and they quite often will just come and jump out of the water and as they porpoise along in big groups. So the chin-strap penguin is another one that we might see. One of the other animals that is very distinctive from the oceans around Antarctica, and they breed on the offshore islands rather than on the continent, are albatrosses. And I don't know if anyone's been looking out to sea at the moment, but we've had black-browed albatrosses, which are ones with a white head, white tail, and just a black, dark sort of back and wings. And if you see them sort of cruising along, I've already seen a few from the ship. So they're very distinctive, and I'll show you a picture of black-brown in a minute. But that's a wandering albatross, which we should come across in the Drake Passage. They're well worth looking out for because they're huge. It's like sort of 787 of albatrosses. And also, we may be lucky enough to see the very beautiful grey-headed albatross. This is at a breeding colony on South Georgia where I worked many years ago. And they're rather smaller albatrosses, but incredibly beautiful. And the one thing about albatrosses is their flight. Their flight is just it's like perfection. And the way they fly, I'll do a talk about albatrosses hopefully in a couple of days' time when we leave Ushuaia. So I'll talk a bit more about that. Right, from the fun bit to the kind of, oh no, not politics. Well, interestingly, I think Antarctic politics is actually in a pretty healthy state. Many years ago, the last century, and Craig will probably talk a bit about this, Antarctica was sort of unknown a couple of centuries ago. Then people started finding it, and the minute humans find a bit of land that nobody owns, they kind of tend to say, this is mine, stick a flag in it. And so that's what all these people did. As someone who's British, I have to hold my hands up and say, sorry, we were kind of worse at doing this than most people historically. So I'm not blaming anyone for any of this. I certainly haven't got a leg to stand on. Yeah. And so that was the early these are the early claims to sections of Antarctica. And people started making stamps, British Antarctic Territory, and Sir Douglas Mawson Centenary, that was the Aussies, I think. These are French, a very Frenchy sort of stamp, and that's an Argentine one, and that's the British one there with the Queen on. And so people started getting very sort of, uppity with politics. And then in 1957 and 58, that summer season, all the people who worked in Antarctica, all the scientists, good for them, so let's all work together for a season and we'll see if we can do some collaborative research. So they all started working together. And the results of that cooperation and collaboration were so good that they thought, well look, this is, we've got to be really careful about what happens to Antarctica. If we let some of these national claims go ahead, people might start coming down and digging for, lithium or copper or something, or doing this, or fishing it out and killing all the whales again, which already had happened around South Georgia. So they started talking a bit about politics, about how Antarctica should be run, and how the whole world was responsible for this one place. And so they came up with the Antarctic Treaty. And the Antarctic Treaty basically was signed in 1959 by 12 countries. Which actually has now been signed by 53 countries from around the world. They all agree that there should be no military activity at all in Antarctica. There should be no land claims recognised. All those land claims that were made in the early parts of the 20th century, they're suspended, but they're not recognised. So no one owns Antarctica. In 1991, there was a kind of environmental protocol about how to behave down there because there were more people turning up, doing science, there was an increase in tourism, and so they agreed on no mineral exploitation at all, and they also agreed there should be protocols for tourism as well. So this became a kind of international agreement to look after Antarctica and treat it well, The original signatories to the Antarctic Treaty have their flags in the middle there, and you'll presumably recognise some of those, and then all the other nations who've joined subsequently have their flags around the outside. And so there's now a really good international agreement that it's an international territory, and anyone who works there is doing it for the benefit of Antarctica and mankind, or womankind, I should say, or any womankind really. So that's what happens at the moment. So, as I say, who owns Antarctica? Outline. So when we go to Antarctica, we are all equal. None of us and none of our countries own any of it. So we all turn up there. We're all individuals, and we are all equal in Antarctica. And I think that's a really good way to look at it. And I think it's really important that we also, with that right, comes a responsibility that we are all responsible for it as well. So that's me being a bit pious. Let's have a look at some of the human activities that do happen in Antarctica. And just very briefly, the two obvious ones are science and ship-supported tourism, which is what we are doing. Some of us may be doing science at the same time, I don't know. So those are the two commonest ways that humans go, sort of find a way of getting to Antarctica. Obviously there are other more niche activities like filmmaking, which I've been involved in with the BBC, and lots of other film crews go down there in a variety of ways. There's lots of challenges and expeditions, and sailing boats go down there, which again, I've done a bit of that. And also there are other sort of slightly more nefarious activities that we don't really want to happen, like illegal fishing. Now, I won't talk about that now, but in my albatross talk, I might mention it in passing. So let's have a look at the two most common activities. One is science, and this is a British base called Rothera with an airstrip, and they support science in the sort of middle of Antarctica. They fly in field camps, and people go and research ice and glaciology and geology and all the rest of it. And if any of you have been watching Bandcamp, you'll probably recognise this ship on the right. And that was taken last season. And when we get to Antarctica, if the weather is good and the captain is agreeable, we might be able to go out on the bows and you get a really nice view from there, from which to enjoy the scenery, or look down at whales, or you never know what you're going to see there. So those are the two most sort of common activities in Antarctica. Less common is things like travelling to the South Pole. So you get people who go to the South Pole and you think that's what Antarctica is all about. But it's not. It's a very niche activity. That is actually at the South Pole. They have to move that pole every few years because the ice is moving. It's all sliding around. And so they keep moving the pole. They have to sort of geolocate it and say, oh no, it should be there. So, right, I'm at the South Pole. No, I'm at the South Pole. No, I'm at the South Pole. So that kind of thing. There's actually also an American base there called Scott Amundsen Base. So let's have a look at what the environmental impact is of all these humans in Antarctica. And there's one occasion when I managed when I photographed something which basically was the impact of both. This is the negative bit, and I don't want to emphasise it, but things do happen. And this was a vessel which was both carrying scientific support to a base, and it was also carrying tourism. So it actually covers both science and tourism, and they went aground just off a big penguin colony, right next to the Palmer Station, down on the Antarctic Peninsula, and it wasn't a good idea. So we have to be very, very careful what we do when we get to Antarctica. Obviously, with a ship this size, we are incredibly safety conscious. That's not going to happen this trip, believe me. But that was back in 1989, and since then things have changed, I think, possibly a little bit. So it just was a warning to the human race that we can't just go charging around anywhere, and we have to be very responsible. So the other thing I would say is it's not just people who go there who have an influence on Antarctica. And that's why we do science down there. Because in fact we all have an influence, and certainly through climate change currently, we all influence what happens in Antarctica. Because, for example, this is a view of the Antarctica in winter with the ice surrounding it, and for years scientists, and this is the value of science, scientists have been measuring the extent of that sea ice. And here is a graph showing those measurements over the last many years, with the blue one at the bottom being the most recent. And you suddenly think, whoops, we've actually, the Antarctic sea ice in winter has diminished dramatically in the last year. And that's a very, very serious kind of point. And I think Sarah is actually going to do a whole talk about the issues of climate change in Antarctica, and looking at it historically and, you know, from a variety of perspectives. So I'll sort of flag up that talk, and I think it's really important to know about these things. Another bit of research has been done recently by a multinational collaborative of scientists. Has been at the Thwaites Glacier, which is over here. And this is a glacier where they suddenly realized it was moving a lot faster than it was. And so they looked into why it was moving so fast. And they realized that, well, normally what happens is you get this big, thick ice shelf that comes down from the Antarctic continent, and it sort of hits the sea floor, and that slows it all down, and then gradually the ice floats out here, and then it breaks up and goes off to sea. If the water here warms up, what happens is it melts the underside of the glacier, and then this bit starts moving a lot faster. And the problem is if you remove that bit, all the bit behind it starts moving faster. So you suddenly speed up the rate at which glaciers are going to move into the sea. So that's one area which scientists are exploring and looking at, and it's really important to know about these things. This is another area using satellite images to track the large chunks of ice that break off ice shelves. I mean, this is a natural process, but if it suddenly starts happening quicker than it has done in the past, then that will unlock some of these glaciers, and they can, again, start moving faster. That was A68, which turned up in 2017. And then we've had this one recently, A23A, which is currently there. We're probably not going to see it, actually. It's just heading off towards South Georgia. But it is at the north end of the Antarctic Peninsula, came out of the Weddell Sea, and is heading that way. And that's about a third the size of Hawaii Big Island, about half the size of Cyprus, and about twice the size of Greater London. So this is a very large ice flow indeed. So that's all the sort of earth sciences that are going on, looking at all glaciological sciences that are going on. But the other thing that climate change does is it affects animal populations dramatically as well. And so it's really important to carry on research in animals to see, look at like penguin breeding and albatross breeding and all these kind of animals, because they are clues to what's happening in the wider environment. So don't forget biological sciences. And I use this picture because, again, it introduces a talk I might do later in the trip. That's actually me 40 years ago. In 1982, actually 1983, on South Georgia, when we weighed some albatross chicks. And I'll talk about some science that we were doing and the relevance of it then and now. So, science, important. And but the most people who go to Antarctica are going down as tourists, and that's the sort of really big numbers these days. So it began to get so large that they started off an organisation called IATO, the International Association of Antarctic Tour Operators. And that basically is an overall body which looks after all the ships who operate in Antarctica, including this one, run under IATO protocols. So we all obey the rules. IATO basically tries to make sure the environmental impact of certain sites isn't too great, and that we all work together and we all sort of avoid each other and make sure that you get a really good wilderness experience for everybody who goes down there, and that the numbers don't get too great. I mean, and it's a very, very good organisation. For example, all the field staff who work down here, including the team who've been talking to you, we all have to do an exam to show that we know what we're talking about, and to know how to behave in Antarctica, to know what the IATA regulations are, and so it's a very well regulated business. This is just a graph, doesn't matter about the details particularly, but that was early days of Antarctic tourism in the mid-60s. That's the late 2017-18 season. There's about 40,000 tourists. This is just tourist numbers on the left. So it's got up to about 40,000 shipborne tourists, and then there's a few others there. So about 50,000 tourists visiting Antarctica in 2017. The two latest seasons for which I have numbers, 2019-20 went up to 74,500. Then there was a dip, obviously, with COVID, when everything went where it went. And then 2022-3, it was well over 100,000 tourists visit Antarctica. So it is getting, the numbers are quite big, but the really good bit about it is that when you go to Antarctica, you will be affected by it. You will find it exciting. You will, it gets you somewhere in here, and you will go home and you will say, this is a really special place. And you will, I think it's really important to go, when you go there, you appreciate this, and you'll go home as a sort of ambassador for Antarctica. And that includes an ambassador for the sort of greater environment, really. And I think that's a really important thing to take home with you. I'll just whiz through a few more pictures. This is just nationalities that go there, this sort of proportion. A lot of large groups of Americans, Chinese, Australians, Brits, Germans, Canadians, and French people, and then 18% other nations, which I think nowadays includes a lot of people from South America as well, who are very interested in what's on their doorstep, which is fantastic, to sort of expand. I mean, there's probably about 50 nationalities on this ship, which is great. So let's have a look at what we might see in Antarctica, very briefly at the end, just to kind of get you excited about it all. Not too excited, because you never know what's going to happen. So this is looking at a glacier from the Norwegian Star last year. As I said, the only bit we're really going to visit is up here, maybe the South Shetland Islands, maybe the Antarctic Peninsula. And I say maybe because, once you leave Ushuaia and start heading across the Drake Passage, anything can happen, okay? So you just have to sometimes change plans. You're in a wild area where the conditions are very extreme on occasions. And if they're too extreme, you have to stop. You have to, initiate plan B or C or D. So I'm not, I just want to warn you that things might change. You might think, oh, well, today we're going to go to so and so. Well, maybe not. We might go somewhere else. We'll always find somewhere, and it'll always be amazing, but it may not be exactly where you expect. So we first cross the Drake Passage, and occasionally, on occasion, as a first view of Antarctica, I've had this. Now, there is an island there. And you think, is that it? And, well, that's a place called Snow Island. And it's one of the less exciting visual areas of Antarctica. But as soon as it gets better, okay? And then if we get down the Antarctic Peninsula, it gets even better still. Oh, there we go. Nice day on the Antarctic Peninsula. And this is the area we're hoping to get to, if all goes well. If all goes well, okay? And you've got, in good weather, it's incredibly beautiful. In bad weather, I think it's also incredibly beautiful. So don't worry if it looks a bit, the weather's rough. It's Antarctica, And I think I prefer Antarctica. Well, no, I shouldn't say this. No, but it is exciting in bad weather. But there's nothing like a nice sunny day. And the other problem is, this is, the Antarctic Peninsula, but as you can see, the sea is full of ice. And so it's really important to be aware of the ice and aware of how the ice works, and to also just not do anything stupid. So because of the ice, we've got, we've got an ice pilot on board, okay? And he's a qualified captain in his own right, and he is working with the captain to make sure we just avoid any ice that might be not a good idea. But ice is good, photographically, because it's very beautiful. And once again, I would emphasize, if you are up late at night, this is late evening, summertime, it's just, I think the middle of the night in Antarctica is the most beautiful, because you get these incredible colors. That was just, half 11 at night, at the end of one trip, just heading off towards back. In fact, we were just about to head across the Drake Passage, and that turned up behind us, and we thought, oh, don't want to leave. The other things, just very briefly, ice, we'll see quite a lot of ice, maybe not quite this close, but we should see some glaciers, we should see some icebergs. Possibly out at sea we might get big ones like this, big tabular icebergs, and we might get smaller ones, which are more sort of pretty and delicate. And we might, and we'll get reasonably close in. So we'll see quite a lot. We might see a base. There's all mites here. We might see some albatrosses. There's albatrosses, Cape petrels, and Wilson storm petrels in here. So we'll certainly see some wildlife. We may see humpback whales that I showed you earlier on, but if we're very lucky, we might see orcas. Also, if we're very lucky and in the right place, we might see fin whales. Those are quite good possibilities, actually. And the fin whale is interesting because on the left-hand side of the jaw, there, and I'm nearly finished, That is grey. On the right-hand side of the jaw, it's white. And that's a really distinctive sort of defining thing of fin whales, characteristic. The other thing we might do, we might visit historic sites. It's just possible, if we get good weather, we might get towards Elephant Island, which is where Shackleton's men got stranded, and so there may be some sort of historical sort of context which we can put on this trip. And I think that basically gives you enough to get you excited, hopefully. You know, I would say we're limited because the weather might limit us and we're on a big ship, so we have to be very, very careful. We will look after you, but we also want you to enjoy yourself and get the best experience. And I'm sure the captain, he's brilliant actually. This captain, we worked with him last year, and he's fantastic. And I'm sure he'll do his best to get you to some extraordinary places. So I wish you the best. Have a great journey and enjoy it. And just take note of that. I think this is the first of our Antarctic headquarters sessions in the Bliss Lounge, 5 o'clock to 6 o'clock. You'll have the whole team there, so you can ask us any sort of questions you want within reason. And so we'd either see you there or I'll be in Gatsby shortly. Thank you.